Hello, everyone. Good morning, afternoon, or evening. Dear authors and invited guests, welcome to Technical Session 12B. My name is Alesha Mullah, and I would be your moderator for this session. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 11th International Congress on Information and Communication Technology, ICICT 2026 in London, UK. The 11th edition of the conference is being organized in a hybrid mode. The physical event was held on the 24th of Feb in London, and the virtual event is being held from 25th to 27th February via Zoom. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes for the presentations and 3 minutes for question and answer. On the 10-minute mark, I will raise a gentle reminder. There is another request to all the participants. Please stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we start the session, I would like to introduce you all to the chair for this session. Professor Nuzhat Faiz Sheikh is a professor and head of the Department of Computer Engineering at Modern Education Society's Wadia College of Engineering in Pune, India. With over 24 years of academic experience, she has made significant contributions to teaching, research, and academic leadership. Her research specializations include artificial intelligence and machine learning, image processing and biometrics, virtual and augmented reality, and soft computing, with a strong focus on emerging and intelligent computing technologies. I request Professor Sheikh to please say a few words.
I hope I'm audible.
Yes, you are.
It's a good evening at my end. Good evening, everyone. I'm speaking here from Pune in India. So it's around 5:30 in the evening. I feel honored to be chairing this session where I think there would be 6 papers that will be presented. Looking forward to gaining a lot of knowledge from all the presenters who will be presenting here. All the best to everyone, and thank you for inviting me.
Thank you, ma'am. We will now begin with the presentations. Our first presentation for today is by Sama Senbel, who will be presenting Analyzing Children's Stories Using LDA Topic Modeling. Sama, you may now begin.
Good afternoon from my side. Let me just share my screen. 1 second. Okay, good afternoon. Do you guys see my presentation?
Yes, we can.
Yes, okay. So my topic is Children's Story Analysis using LDA Topic Modeling, and this is the work of my 3 students, Madhurya Chatrasi, Sri Deepika Madhu, Triveni Nooni, and I'm Sama Sandberg. This was for our text analytics class at Sacred Heart University, which is in Connecticut, the USA. So this is your work, but they can't present because they just graduated, so I'll be presenting instead of them. So this is an overview of our talk. We'll start with a quick overview of what we're doing. Then we'll talk about our data set, what pre-processing we did for this data, our LDA topic modeling results. We'll look at the examples of our topics. Then we did some emotion and sentiment analysis for our data set and some visualization, and then we'll conclude our speech. Okay, so an overview of what we did for this project. So what we did is we corrected data of children's stories. We collected about 430 students' children's stories. For each story, we have the title, a summary, and the text itself. Those stories come at different levels, from toddler level stories, which have like a few words in them, to stories meant for teenagers, which is really like a full-size book. We use natural language processing to look at the themes, emotion, and narrative patterns of those different types of books. Those books are all in English and all have been published within the last 50 years. And this is what we did to them, basically, some topic modeling, some emotion analysis. We did, of course, vectorization and some visualizations as well. This is really to help look at how those books are different and which one to pick based upon the interest of the students. It's important to categorize those books into different groups. Okay, so like I said, our data set, We have 430 different story records in text. For each story, we have the author, date of publication, a brief summary of one paragraph, and then the text of the whole story itself. We have 390 unique story titles because some of them are like, part one, part two, like the Harry Potter series and so on. Each book has a different age category from, baby books, toddler books, preschool, and so on. And the biggest being teenage books. Each story of them acts as an independent document and it's a whole different book by itself. We used TF-IDF to vectorize our data and we had about 5,000 numerical features from that. Okay. So the data set is public itself. We just collected the different books. This is what we did for our pre-processing pipeline. The text came in nicely clean. There was not really any errors or anything in them. We did some very basic text cleaning. We converted all the text to lowercase and we removed all the punctuations, numbers, white spaces, and so on. So basically minimal cleaning. Then we did some tokenization. We just split the text into individual tokens and then we did lemmaization by reducing each word to their root. For example, player, played would be play, and so on. Reader, read will be read, and so on. So this is just getting the words back to the roots. Then we did the very famous TF-IDF vectorization, which I'm sure you guys are familiar with. This will actually give a numerical value to each word based upon how frequent it appears in each word. We had about 5,000 different features. And then we did some emotional tagging. Basically, we divided the words into feelings, for happy, for anxious, for fear, and so. Our main goal really was to divide those groups into different topics. So we used the very famous latent Direct association, which is a very famous technique for topic modeling. We used the Python programming language, and it took us about, I don't know, maybe 2 or 3 hours to run the code. We picked an optical topic count. We used 5 topics for that, and then they were mapped into different groups. So our algorithm discovered that we really have 5 different themes from running this algorithm. Friendship and cooperation, nature and fairy tales, family and learning, childhood and play, and then explorations and imagination. So let's look at the results of our topic modeling. So like we said, this is the topic models we had. There's 5 of them. And this slide shows you the most common words in each group. So topic 1, the most common words was book, life, story, children. Topic 2, the most common words, if you will, little, story, book, classic. Topic 3 was family, life, adventure, school. Topic 4 was baby, school, fun, play. And topic 5 was story, word, imagination. This is just the most popular words in each group. And each of them had a very different data set. But a couple of topics were very similar. Now, this is the visualization of our topic modeling. If you see here, we have 5 circles of different sizes, right? So the size of the circle shows you really how popular this topic is among our data set. So this is topic 1 over here, topic 2, and then 3 down here. This is 4, and this is 5. As you can see, those 3 topics up here, topic 1, 2, and 4 are pretty similar, right? Topic 3 is very different, and topic 5 is very different as well. And on this side, you see the most popular words in all of them. So these are the books divided into those 5 groups. As you can see, you can also divide them into 3 groups if you want. Those will all be one big group, and those 2 are very distinct than the other groups. So let's have a quick look at them one by one. So this is the first topic over here in red, and this bar here shows the most popular words in each group. So as you can see, this is about a quarter of our data set belong to this topic 1. This is really focusing on core storytelling elements such as book, life, story, children. And those books really reflect fundamental themes, mostly really for toddlers and younger children. The second topic, which is in this circle up here, as you can see, it overlaps a lot with topic 1. These are the most popular words in each group. And this includes terms like little, story, book, one, new, young, and so on. These keywords indicate the presence of fairy tale structures, childhood adventure themes, and story format that appeal to younger readers. Once again, this group was mostly for the younger students, toddlers, babies, and early school. Topic 3 was actually quite different, right? This one emphasized family in general. So this had family-oriented keywords such as family, life, adventure, and school. This highlight really narratives that deal with relationships, growth, and educational development. This really was targeted for school-age children and preschool students. As you can see, it's a very distinct one from groups 1 and 2, and it's also smaller in size. The next group was group number 4. As you can see, it's much smaller. It's about 12% of our data. And this really talks about early childhood as well, centering on play, learning, and interactive storytelling. Now, the last group over here, number 5, this was very distinct from the others. This was really mostly the books for the teenagers and the older school kids. This one talks about creativity, exploration through keywords like word, discovery, life, imagination, and so on. This is about curiosity, problem solving, and emotional growth. And looking at those books, they are mostly the, like I said, 12 and above age group. So those are the 5 groups of our books. We also looked at the emotions in those books. How are the emotions different among the different age groups? This is quickly our results, right? So as you can see on this bar over here, we divide it into, just to make things simple, 3 groups: toddler groups, which are books really of about 500 words or less. This is the middle group, mostly for elementary school kids. And this is our older data set for teens. So we did some very basic sentiment analysis, and this is our kind of different feelings, emotions we have. Sadness, trust, this is neutral words. Joy, anger, surprise, fear, anticipation, and disgust. And we notice something. Look at the toddler group, the younger groups. There's lots of books about joy in general and trust. This is really the main target of those books, a very high count on those fields. As you go up in age, you notice that kind of there are less of these groups, and then you have a new group here, which is fear. This is for elementary school. So you have things like fairy tales about, monsters and stuff like that. So the pattern differs, and some anticipation books over here. So there's lots of feelings for the younger books. Look at the teen books. This one is very different. This is most about, adventures and things happening and news and so on. So you see very less emotional words compared to the other groups. So you can see that there is less investment, if you will, in sentiment for this age group. Okay, last thing we did is we looked at just the main characters' names, and we noticed an interesting pattern. This is in all the data sets. The most popular actually character written is the name Jack, oddly enough, followed by Tom, Calvin, Mom, which is for mother in general, Michael, Omar, Charlie, and then Mary. Mary Poppins and June. Notice how there's more male heroes, if you will, in those books compared to ladies. You can see here Mom, which is a common thing for mother. And you see here number 8 is actually Mary. This is the first female name, if you will. So most of the books really have male characters compared to female characters in our data set, at least, which we're not really happy about, because this is really an all-female group working on this. So to conclude, this is what we did. We used LDA topic modeling to look at the major themes in children's stories. We looked at imagination, family, friendship, play, and exploration. And this is different for each group. We looked at the different feelings as well to look at the children literature. And we noticed that the younger ones mostly emphasize joy and trust, particularly for the toddler age group. Older groups showed greater emotional depth, looking at anticipation, sadness, and more complex storytelling element. This is mostly for the school-age kids. For teenagers, it's mostly about a narrative and not really much of emotional stuff. We used natural language processing as a scalable, objective approach to understanding literature on a wide scale for 130 books. And then this really is a nice project that bridges technology and storytelling, offering insights for educational parents and researchers about the different books and how they compare each other. We would like to incorporate like some AI into looking at richer topics and hopefully more books in general. We want to work on a different language because all our books are in English in the last 50 years. And we would like maybe to kind of incorporate this into like, a personalized recommendation system for books for, mothers or librarians and stuff like that. This is our future work for this project. And that's it. Thank you very much. Any questions, please?
Thank you, Sama. That was a nice presentation. I just had one small query.
Yes.
After you identified the topics using LDA, how do you connect these topics with the emotions identified using the NR lexicon?
Yes, actually, those are two separate things. So after we divided the 5 groups, right? Remember, each of them had like a field that says what age group it is. So we noticed that group 1 was mostly, 1 and 2 were mostly the toddlers and the preschool groups. So this is how we connected both of them. We had a particular field that connects both fields together. And this really helps in doing that.
All right.
Yes, thank
Thank
you for
you.
your, yes.
Thank you. Thank you for the answer. If anyone else has any questions, otherwise we can go ahead with the next presentation.
Thank you.
All right, we'll move on to the next presentation. So next, we have Manal Ek, who will be presenting enhancing reaction time prediction in air traffic control using machine learning, linear regression, and k-means age-based clustering. Manal, you may now start your presentation.
Good morning, everyone, from my side.
Good morning. Please go ahead.
My name is Manalish, and today I will be presenting our work named Enhancing Reaction Time Prediction in Air Traffic Control using machine learning, linear regression, and k-means age-based clustering. So this research focuses on improving cognitive performance prediction in safety-critical aviation environments using k-means clustering and linear regression. First, we'll talk about the problem, the research context, the state of the art, then the gap in the literature, and our proposed approach, the results, and the future perspectives of our work. So first, air traffic control is one of the most cognitively demanding professions in the world, and controllers, they must maintain sustained vigilance for long periods under time pressure and in dynamic environments where even small lapses of attention can have serious operational consequences. Fatigue-related human error remains a major safety concern, and reaction time, which is measured by the psychomotor vigilance test, has been proved to be a validated behavioral indicator of alertness and cognitive performance. However, the existing fatigue prediction models, they mainly rely on sleep, history, and caffeine intake, and they fail to capture a real-world cognitive variability. So the core problem is that the current alertness models, they underestimate human cognitive variability. They often ignore stress, age-related cognitive differences, and contextual variables such as workload. As a result, reaction time is frequently underestimated, reducing the reliability of performance prediction in operational ATC settings. So our objective was to build a multivariable AI-supported model, that is the long-term objective, that better represents real cognitive behavior. This work is positioned at the intersection of neuroergonomics, artificial intelligence, and aviation safety. It extends the well-known To Be Alert web model, which is an available platform, and it integrates other behavioral and psychological factors. Fatigue modeling traditionally relies on sleep, wake, history, and circadian rhythms. The To Be Alert web model predicts reaction time based on sleep and caffeine consumption. In aviation, these models are widely used for fatigue risk management, and the psychomotor vigilance test is the gold standard for measuring sustained attention. Reaction time degradation reflects reduced executive control and attention capacity under fatigue. Recent researchers, they use physiological sensing like the electroencephalogram variables, the different electrical brain electricity scales, also the heart rate variability and eye trackings combined with machine learning. Yes, but these systems are often costly, complex, and mainly tested in laboratory settings. Thus, it makes them expensive, complex, and difficult to deploy operationally. And also, many studies that use these variables, they only use few variables and not an integrated model. So our first step was to build a multiple linear regression model. We thought that it can be a good baseline for the work. Reaction time was modeled as a function of age, sleep duration, stress level, and caffeine intake. The equation used ordinary least squares estimation. The goal was to quantify the contribution of each factor and provide an AI-enhanced prediction beyond sleep-only models. We then applied k-means clustering based on age because we observed that age has a major impact on reaction time in real operational settings. The optimal number of clusters based on the elbow method was 3. This allowed us to create a younger group, a mid-age group, and an older group. For each cluster, we built a separate regression model, and this captures age-specific cognitive variability and improves interpretability. Moving to our data set, it included 39 ATC trainees in 4 experimental days with 156 total observations. Each participant completed a 60 minutes aerodrome control simulation, followed by a 3-minute psychomotor vigilance test. Our variables included sleep duration, caffeine intake, stress level, and age. The model was implemented in Python. The correlation heat map, it showed that reaction time increases with stress and age. There was a slight decrease in sleep duration and weak individual correlations. This confirms that performance depends on combined factors rather than isolated variables. The average measured reaction time was 262 milliseconds, with a standard deviation about 20 milliseconds, indicating moderate variability. The mean difference between measured and predicted values was 13 milliseconds, and the correlation coefficient was 0.216, which indicates a weak positive relationship between the results of the 2B Alert Web platform and the real measured results. So when comparing the models, the traditional 2B Alert Web showed a negative R-squared, meaning a poor predictive performance. It actually underestimated the reaction time. Our regression baseline model, which improved, actually the mean absolute error reduced from 21.57 milliseconds to 1491 milliseconds, and the root mean squared error reduced significantly. The R-squared improved to 0.12. It is not actually enough. It's still modest, but it demonstrates that including at least 2 variables such as stress and age improves the realism of the results because it gave better results than the 2B Alert Web. So these results indicate that reaction time is not determined by only sleep and caffeine as in the published platform. Actually, stress and age significantly influence performance, and the relatively low R-squared suggests nonlinear effects remain, which means that in our future models we should move in toward more advanced AI methods and with a bigger data set. Importantly, younger participants showed more stable performance, older participants showed greater variability, and this supports that fatigue prediction should actually be personalized. So the future work includes moving toward random forest and deep learning models by integrating multimodal physiological monitoring and developing an adaptive ATC systems that adjust workload based on predictive cognitive states. And this aligns with the evolution towards neuroergonomic AI systems in aviation safety. To conclude, traditional fatigue models underestimate real reaction time. Actually, stress and age are essential predictors of vigilance. Also, AI-enhanced multivariable models better represent human cognitive variability, and a reaction time is not simple linear output of just 2 variables. It actually reflects complex and individualized processes. This study finally supports the integration of AI and neuroergonomics for safer, human-centered air traffic systems. That's it. Thank you for your attention.
Thank you, Manal. That was a good presentation. I just
Thank you.
have a very small query. What was the reasoning behind choosing linear regression for prediction? Like when you choose
Actually,
when you choose linear regression, the time may have non-linear patterns. So, what
yes.
was the reasoning?
Actually, it was just for the start. We thought that in order to quantify the variables, just for the beginning, for having a baseline, we thought about using a linear regression. But after that, we will try to use a random forest and other machine learning models in order to capture the nonlinear effects.
Okay. And what was the rationale for using age as the primary clustering variable in k-means?
Actually, it was two reasons. Before we used a principal component analysis, and we observed that the coefficient related to age was high, and also in observing in operational settings environments, we observed that age, the reaction time of people different relating to their age. So we thought about using age clustering was better.
Okay. Other than age, what other cognitive or workload related factors could be considered?
Actually, in the number of traffic, for example, can be considered. Um, the lighting, the time of the shift, the duration of the shift, many other variables can be used.
Okay. Thank you.
Thank you.
All the best.
Thank you so much.
Okay, we will now be moving on to the next presentation for today. So next we have Eleni Kustriava, who will be presenting Independent Movement and Audio Haptic Game Performance in Individuals with Visual Impairments, a Correlational Study. Eleni, you may now begin.
Thank you very much. Oops. Okay, my name is Eleni Kustriava. I'm coming from Greece, specifically University of Macedonia. Here I'm an associate professor, and we are going to talk about independent movement and audio haptic game performance in individuals with visual impairments. This is a correlational study, and actually it is a part of an extended research studying the mobility of individuals with blindness and the effects of an audio haptic memory game. That was a project funded by the Hellenic Foundation for Research and Innovation, and the implementing body was University of Macedonia. The Blind Mobility Project actually had targeted to map the way individuals with blindness travel across city area before and after using an audio haptic memory game. And actually the aim was to see if the audio haptic memory game can increase the way people represent the city area in their mind. They build their or they improve the cognitive map, and of course the way they travel across the city area. A few words about the background. It is widely accepted that when people with visual impairments move, and the more they move, the more socially included they are. And this seems that it indicates that if we do not promote access and mobility in urban areas, actually this will reduce this actually will lead to social exclusion of persons with disability. In this way, urban planners and designers who are responsible for creating inclusive environments environments need to fully understand the needs of people with disabilities, which are very heterogeneous, and take into account their lived experience and the barriers they actually face in their daily traveling. However, many individuals with visual impairments continue to face serious obstacles in daily travel, suggesting that current accessibility measures do not yet meet their real-life mobility needs. For this purpose, many orientation and mobility aids appeared from time to time. Initially, tactile maps emerged as an effective tool for supporting spatial orientation and independent mobility, but tactile maps very early proved to be limited in supporting spatial orientation and mobility, and thus they soon were substituted by audio tactile maps, which provided new opportunities for individuals with visual impairments in order to understand the spatial layout of cities and to manage their route. More focus has been given on 3D technologies, which offer a controlled yet realistic environment for orientation and mobility training. Though numerous applications targeting orientation and mobility for individuals with visual impairments have been developed, these tools usually fail to provide a quick overview of the spatial environment that someone wants to visit. And in addition, these technological developments should be informed with data and feedback directly collected from individuals with visual impairments, ensuring that these systems truly meet these people's daily mobility needs. Thus, our study aimed to investigate whether potential correlations exist between the performance of individuals with visual impairments in an audio-haptic game concerning a city center and various variables related to their free movement across 4 routes within the same areas of the city center. 11 participants with visual impairments constituted the sample of this study. 8 of them have blindness and 3 severe visual impairments. All of them have visual acuity less than 1/20th. The onset of their visual impairment was congenital in 7 participants. The mean age was 38.3 years old, and 9 of them are males, while just 2 of them are females. 5 participants stated that they move independently, while 6 participants reported that they sometimes need some kind of assistance by a sighted guide or a dog guide, and sometimes move independently. The instruments we used in this study is first the Novin Falcon haptic device. It's a haptic feedback device. The device allows for 3 degrees of freedom, up, down, right, left, and forward, backward, through the movement of ground grip. The audio haptic map we developed, it's actually a gamified map including the city area, the city center area, the city center, the center of Thessaloniki in Greece, corresponding to the same area that participants were engaged in free movement in the first part of the study. The haptic stimulus, the game, was perceived as individuals moved along the map through intersections. With the addition of audio information, participants could hear the names of the intersections. They could receive auditory feedback about the distance traveled from a starting point, and also they could hear the street names and the sounds from the environment. We included a soundscape in the map. And then while they're free movement, the participants' routes were recording using Mobile Mapper 50 GNSS and the respective software. The Mobile Mapper 50 is a high accuracy, offers high accuracy geospatial data collection, which was very useful for tracking the participants' routes. This is the Novin Falcon haptic device, haptic feedback device. And this is the map, the haptic map where participants navigated using the Novin Falcon device. As you can see, there are points in the intersections in order for the for the users to receive the haptic feedback and listen to the name of the intersection. Regarding the procedure, participants were asked to play the game in order to learn as much as possible about the area where they would subsequently move freely around the city center. The game consisted of the familiarization phase, the main test, and the evaluation phase. For the familiarization phase, all the instructions on the device functions and the button use were given. Recommendations for effective navigation were also given, such as maintaining a low and steady speed while navigating the map. Elements of the game's digital environment, such as streets, intersections, and soundscapes, also were explained. And of course, the goal of the game that was for the participants to memorize the specific area as accurately as possible. The main test consisted of 5 tasks with a total duration of 1 hour. Task 1 was to walk along all horizontal and vertical streets on the map. Task 2 was to locate and walk along 2 streets predefined by the researchers. Task 3 was to locate 3 streets on the map predefined by the researchers. And task 4 to locate 5 intersections predefined by the researchers. For the final evaluation, 3 tasks were included. Task 1 was to locate 2 streets on the map, task 2 to locate 4 intersections on the map, and task 3 to follow a route passing through 4 intersections. Researchers just predefined the starting and the ending points. No time limit was imposed for the completion of the tasks. Participants could navigate until they found the requested location, but the time was recorded. Then, when participants finished with the audio haptic game, they were asked to navigate 4 routes across the city center. Again, I'm saying that the city center, the area they were asked to move, it was the same area that it was presented on the audio haptic map. The researchers predefined only the starting and the ending points for each route, while participants were free to choose their own paths to reach the destinations. The order of the routes was rotated for each participant in order to avoid potential effects of fatigue on their performance.
Excuse me, I'm so sorry, but you have less than 2 minutes left, about 1.5 minutes.
Okay, thank you. So I can skip this. And for the analysis, the data recorded by the GPS device was stored in DXF format and converted to KML format. Each route was imported into Google Earth, which supports KML files and enables their visualization on a map of the area. In total, we had 44 maps for each participant. To evaluate the characteristics of the participants' routes, the following 6 variables were taken into consideration: travel time, route, changes in direction, pauses for any reason, disorientation or a wrong path, and help requests. The analysis revealed a statistically significant positive correlation between the variables time and task 1, as well as between the variable help requests and the variables task 2 and also tasks total, which means that participants who required more time to complete the routes during their free movement across the 4 routes also needed more time to complete task 1 of the audio haptic game. And furthermore, participants who exhibited a higher number of help requests during their free movement also took longer to complete task 2 as well as to finish all the tasks. Okay, so the findings of the study underscored positive correlations between participants' performance in audio haptic game and the parameters related to their free movement. These findings are in line with the results of previous studies. Previous studies also prove that individuals with visual impairments can indeed walk and orient themselves and even detect points of interest in the physical environment after having studied the same area mapped within an audio haptic application. And in agreement with these studies, also, Simonette and her colleagues found that tactile and haptic digital representations are equally important orientation and mobility tools, but according to the researcher, this was not expected since participants with visual impairments are not experienced users of force feedback devices as the Novint Falcom. Hence, the present study proves that audiohaptic maps, especially when delivered in the form of a game, can be used as functional orientation and mobility aids for individuals with visual impairments, since they clearly improve their movement in urban areas. Mobility within urban areas is by definition challenging, and thus any relative aid is valuable for individuals with visual impairments. So a repeated exposure to gamified spatial tasks could influence over time spatial learning retention and or long-term mobility behavior for individuals with visual impairments. Thank you very much.
That was a nice presentation, Eleni. You have a lot of work to show, but time was limited. I can understand. Uh, what statistical method did you use to measure the correlation since this is a correlation study? Which method
Uh,
did you use?
Yes, we performed the Pearson correlated analysis. Unfortunately, the sample is very restricted. It is not easy to find participants with visual impairments who will be eager to participate in consuming time tests and tasks. So the sample was limited.
And
Thus,
what was your sample size?
11 participants with
11
visual
participants.
impairments.
Okay. And how did you quantify the game performance? What was it based on the accuracy or the completion time or error
Uh,
rate?
Actually, we used both the time they needed and the accuracy, but in order to have more unified, let's say, data, we used the time. And of course, in the context of the extended project, we made more quality um, uh, analysis in order to enrich the
Okay.
data and the results.
All right. Thank you. All the best.
Thank you very much. I'm sorry for the extended
It's fine.
presentation.
No worries. We'll now continue with the next presentation. So next up we have Pramila Fanu, who will be presenting Intelligent Adaptive Control Framework for Multimotor Electric Vehicles, Integrating Artificial Intelligence, Information Technologies, and Sustainable Embedded Systems. Pramila, you may now begin.
Hi everyone. Can you hear me?
We could not hear that. Pramila, could you please speak up?
What did you say?
Oh yeah, we can hear you now.
Okay. So I just would like to share my screen. Yeah. Well, everyone. I think that
Excuse me. We can see your screen, but you're not clearly audible. Your voice is breaking a lot.
okay. Please let me check it. What is traffic? How many companies?
I'm still not able to hear her, Alicia.
Yeah, we'll just wait for a while for her to fix it.
Yeah.
Okay. Is it good now?
Yes, it's all right.
Yes, that's
We can
better
hear
now.
you.
Okay. So I'm going to share my screen another time. Okay, are you seeing my screen?
Yes, we can see.
Okay. So, good morning, everyone. Chair Technical Committee, Chair colleague, good morning. My name is Fan Primela, and I'm a PhD student in the National School of Art and Craft of Rabat in Morocco. And I'm here today to present you the results of my work entitled Intelligent Adaptive Control Framework for Multi-Motor Electric Vehicle, integrating artificial intelligence, information technique, and sustainable embedded system. So this work was done in the this work was done in the laboratory of Hertz in Mohammed V University under the supervision of Ms. Khalida Zazi and Mr. Kaya Marwan. So to dive into this presentation, no. Okay. So to dive into this presentation, I prepared an outline subdivided in four big parts. First of all, we are going to introduce our subject and extract the problematics of this one. Then I'm going to present you my framework and show you the different experiments on it and the key results. And then we are going to conclude our presentation. So we know nowadays that the evolution of the technology, especially in the automotive field, allow us to have the new kind of electrical vehicle, which is the multimodal electrical vehicle. So this kind of vehicle allow us to have a more efficient optimization about the energy consumption in the vehicle, a better torque allocation, but these advantages come with some kind of disadvantage. So the problem statement of our presentation is how can a multimodal electric vehicle achieve a real-time adaptive torque allocation using AI while guaranteeing closed-loop stability and improving energy efficiency under dynamic and uncertain conditions. So, uh, before diving into this presentation, I want to say that the main contribution of this paper is, first of all, a unified intelligent adaptive control framework using the combination between a IOC, deep reinforcement learning, and the metric of Lyapunov stability. Our architecture are ICT aware, and we succeed to make it preserving the stability while being online. and we demonstrate improvements done by this architecture. So, before getting into the technical part, we have to make a state of art of the domain. So, after doing the state of art of this domain, we can say that we have three big methods for the talk allocation. We have the model-based method, which are mathematical rigorous, but are very limited in terms of adaptability. And in the second hand, we have the advanced adaptive control method, which can allow us to have the adaptive optimal control, improving the robustness of the system, but is very limited in terms of learning capability. And then we have the A-based method, which has a learning policy from data, have a strong ability to adapt under uncertainty condition, but it's not formally guaranteed in terms of stability. So the architecture we are going to propose today will bridge the different limitation of the already seen strategy by allowing us to combine an advanced AOC, which is mathematical rigorous, and giving us the adaptability and the learning rate we were needed by implementing the EA. So our architecture is divided in three big parts. We have the first one, which is the hierarchical control. We have a high level of learning, and by using a mid-level talk allocation, we have the integration of the ICICT, like a real-time feeding using communication bus such as CAN, FT, and MQTT, and the meta learning enable fast adaptation to changing conditions. So the theoretical foundation of this architecture is based on the Hamilton-Jacobi Bellman formulation, and we are using a PPO to update a PPO which we apply a Lyapunov gradient to ensure the stability. So this allows us to guarantee safe online adaptation under system uncertainties. So concerning the vehicle model and parameter, we try to simulate a Rivian class quad motor EV by having four different and independent motor. We apply the aerodynamic drag, the rolling resistance, and we implement the longitudinal dynamic and also the mechanical loss. So for the parameter, which you can see here, we use the vehicle mass real radiant of a real vehicle to guarantee how can we say, to guarantee a real-time simulation or real-time improvement that our model can demonstrate. So for the experimental setup, we make our simulation of MATLAB Simulink using a simple hardware and running 20 tests on driving cycle, such as the NEDC, the WLTP, or the US 06. So concerning the results, we choose to analyze our architecture on four different metrics. So the first one is the velocity tracking. So our architecture is the best, which follow the reference we gave, and reduce overshot and steady state error is faster to adapt to acceleration and deceleration, and had a smooth control transition due to meta learning. About the energy efficiency, we can say that compared to the MPC, our architecture have 10% improvement. And compared to a simple DR IOC, we have 7% better than DR IOC. And our architecture has a top redistribution optimizing, and we gain a consistent energy across all test run. So concerning the stability, like I already said, we apply the Lyapunov function, and here on the figure we can conclude that we have a stable learning through the online adaptation due to the fact that our Lyapunov function strictly decreases, and that confirms our theoretical stability guarantee. So concerning the power consumption, we have a shorter power peak, but lower global energy integration. We have smooth transition, which reduce loss and system stress, and that highlight the real-time efficiency advantage. So concerning the information and communication technology integration and the sustainable part of it, like I already said, our architecture is able to implement real-time communication, thus such as KNFT, MQTT, or Ethernet. The edge computing reduce the latency and the cloud dependency. Our system is energy aware that allows us to have an adaptive torque distribution. And the fact that we are using a lightweight certification for adaptive control allow us to guarantee the cybersecurity of this architecture. Concerning the sustainable part, we see through the different results we get that we had energy reduction. Energy reduction is lower CO2 emission, and that will reduce by the same way the computational cost.
Excuse me, I'm sorry to interrupt. You have about 1.5 minutes left.
Okay, I already done. So concerning the energy and CO2 impact, we can say that we had a big reduction of the CO2 emission per year per vehicle. So our system or our architecture reduce the carbon footprint is and sustainable embedded intelligence. So for the perspective for this work, the next step is to go to a hill process, try to implement it on the real essay, try to develop the cybersecurity part, and try also to make it cooperative with the virtual inks while while integrating it in the smart grid system. So to conclude our presentation, we can say that the proposed architecture through this presentation combine AOC and intelligence artificial with stability metrics that will guarantee us an online learning. We achieve not the best, but very significantly result through the energy consumption of the energy efficiency for the torque distribution. So that's all for me. I hope that I show you guys new things. Thanking you for your attention, and I will be more than happy to respond if you have any question. Thank you.
Thank you, Pramila. One small question. What type of AI technique did you use in your framework?
I use a deep learning, a deep learning, a deep reinforcement learning, and I apply a PPO policy on it.
Okay. Any specific reason behind choosing reinforcement? Why not rule-based methods?
Yes, I choose the deep reinforcement learning because in our situation we have we are using the vehicle in a real life condition, so we have so much uncertainty, like the road condition, the road condition, the weather, everything. So we will have so much uncertainty. We have to have a model which can quickly adapt the system on the uncertainty. So this is why I chose the deep uh, relearning enforcement.
All right. You have spoken of a sustainable framework. So then, how does your system contribute to energy efficiency compared to the traditional EV vehicles?
Okay, so the traditional EV in terms of torque allocation are not energy aware. Because if we take an example, we have a EV which had, let me say, uh, two main system. For the torque allocation, it will normally make 50-50. But if we are in a situation we don't need 50-50, we maybe need like the torque inject in the system with a traditional vehicle will always be 100%. But if we have an energy aware system, we will know exactly how much we need to inject in the system. And by that, we will have a reduced energy injected into the system. Maybe in a situation when we have with traditional vehicle made 100, with our system we are going just to make we are just going to inject maybe 15 50%. Then we have already gained 50, and that's how we can say that our framework is sustainable and energy. And the fact that it's energy aware is a level to say that our framework is sustainable.
All right.
I don't know if I respond to the
Yes,
question.
yes. Thank you. Thank you very much.
Okay, our next presentation today is by Sama Senbel, who will be presenting predictive analysis of H2B visa applications acceptance rates in the USA using machine learning models. Sama, you may now begin.
Yes. Okay, good afternoon, everybody. It's me again. Okay. Let me start my presentation. Okay, hope you guys can see it. Okay, so the topic of this paper is predictive analytics of H-2B visa application acceptance rate in the USA using machine learning models. And this is the work of my students, Sai Sharan Shinu, Danush Upatali, and I'm Sama Sanbal. We are from Sacred Heart University, which is in Connecticut in the United States. And this was for our machine learning class. So just a quick introduction. So those students were actually graduate students looking for a job after they finished their master's degree. So they were very interested in an H-1B visa. So we were looking at the chance of getting accepted. So this is our work. We looked at the H-2B visa program because it is an important role in filling jobs in the US, especially in industries that face chronic worker shortage, mainly in the labor field as well as the technology field as well. We looked at 17 years of federal labor data, and then we looked at how all the different economical, occupational, and regional factors shape the approval. So when you apply, you get an approval for yes or no. So our data set is the applications made by the employers, not the employees. So if let's say a company wants to hire people, it sets out an application for, let's say I want to have 10 cooks for my restaurant. And then you would get a yes or a no answer for that. So we look to see which states in particular and which industry rely the most on temporary foreign labor and why. So basically which state to go to if depending on what your job is. We looked at how the machine learning would be able to predict the outcome of yes. So hopefully they will put the correct state for whatever job they're looking for because it would have a better chance of being accepted. We looked a little bit on how the trends shifted among months and years, but we didn't really finish this part of the project yet. And then we looked at the different factors that affects the acceptance rate, like what kind of position you're looking for, how many workers they're looking for, the title, the location, and so on. So this was our goal. The data set is public. It's published every year by the US government. So we collected this data for the years between 2008 and last year. This is really a very simple table that includes all sorts of details about each application. It covers the employer company, their name, how big they are, different things like that, which state they're on, what occupations they're looking for, and then the most important, of course, is the outcome. Is it a yes or a no? The dataset includes key administrative and economic attributes such as the title, the work site state, number of workers requested, the wages expected, the case status, and then the filing and decision dates. It contains also things about the processing time and occupational classification fields, enabling analysis and measurement for those fields. And we then would do some very simple visualizations to look at the results of our analysis. Okay, so the pre-processing was once again pretty simple. We have the data set published every year, so we had to merge all the data sets together, which was a very easy job. We had some duplicates because companies had like filed multiple times for the existing job, so this was easy to fix because sometimes there's an issue. We found some very simple like misspelling text and so on, which we did fix as well. And then we make sure all the attributes are standard among the different years. There were some missing values, but maybe about 10 altogether, which you put them as unknown. There was some errors, like we said, outliers. There was a typo or something, and like a state that does not exist. If we can fix it, we fix it. If not, we just remove those fields. And our target field is the yes or no, accepted or not accepted. Some of the text field, we made them into like a category field by using one hot encoding. The coding was done using Python, and we used different libraries like everybody does, pandas, numpy, matplotlib, and so on. Okay, for testing, we tried two different models, which were the one the students were studying, logistic regression and random forest regression, to see which one would work better for our data set. The data set, we divided into groups. We have 75% for training and 25% for testing. And like we said, all the text features, we made them into the one-hot encoding to be able to use them for our analysis. And the numerical values were all scaled so that there's no one factor that kind of balances things off. We looked at the different models, both of them, which one gave us better accuracy, precision, recall, and so on, to see which one is better suited for our data set. Then we looked at the features that had the strongest effects, such as the job wages state, to see what influences the approval decision. Quick reminder, we did use the random forest. It's a very well-known technique. Basically, you would have multiple decision trees, and then you would do like an averaging of the vote. It's very well-known. The other one was the logistic regression, which is just very much like the linear regression, but you would do a curve, not a linear line. This is just showing the results, the confusion matrix for the logistic regression. This is our test cases. As you can see, this is the dark blue one. This is how many were predicted to be accepted and were accepted, about 5,000, which is good. This is how many we guessed will be denied and were actually denied, about 2,000, which is good. Only 10 cases actually were we predicted they would be accepted and they were actually denied, which is a very good result. And about 200 we predicted will be denied and actually got accepted. This is just the output of our results. As you can see, it's pretty strong results. So really the data set really did work well in predicting. So next question is, which one was better, random forest or logistic regression? If you look at the results in this table, here we have the accuracy, the denial prediction, the denial precision, the denial recall, denial F1, and then for the acceptance, the precision recall and F1. As you can see, both of them gave us very high accuracy, so it's pretty predictable, acceptance or rejection for our company. For the denial, actually, you can see both of them gave us excellent results in the denial one. So we're very good at predicting the denial of saying a no for this case. However, for acceptance, actually, the logistic regression did pretty well compared to the random forest, which is not perform well at all in the accepted rate. So we really recommend that for our data set, the logistic regression was actually much better in both the yeses and the nos, if you will. Okay, now next is which feature really affected the decision for yes or no. If you look at this chart, you can actually see that we have several factors here that really strongly affect the decision, and some of them with very little importance down here, right? So actually the top one really was the full-time position. Is it full-time or part-time? And as expected, really, if it's a full-time, then this is actually a good predictor of being accepted. That clearly full-time jobs really have a major impact on approval likelihood. Okay, so at the top two is actually full-time position is accepted, yes or unknown. Sorry. Okay. Follow this is the visa class job. Like what exactly is the job type? Which one would you like, laborer or technology and so on? This is number three. It affects that which class are you in. Next one was the number of workers. We noticed that companies that require more workers typically get more yeses than smaller companies, which is actually a very bad thing because, if you're a small company, you really want two or three or four people. It's very hard to get approved compared to a big company that requires hundreds of people. Those are actually much easier to get approval. My guess is maybe they have a better history of, getting no problems or issues. But this is an important factor is big companies really tend to get, better acceptance than smaller companies that require one, two, or three people only. Next, we look at the states, right? Which states get accepted, and this shows the map of the US, and you can see that the results are different for the different states. If you look at Texas down here, this is actually the one that has the highest application and the highest approval as well. Followed by Florida over here, down here. This is mostly a tourist area and lots of farming and so on. Followed by the Northeast area where there's lots of tourism as well and industry and so on. So we have really three big areas, if you will. The South over here, right? Florida where lots of tourism and then the Northeast. So most approvals are in the southern and coastal states, especially Texas, Florida, and California. Those rely heavily on tourism, construction, landscaping, and hospitality, which requires large seasonal workforce. The warmer climate shows higher approval rates because they have, longer seasonal employment and lots of farming and construction jobs as well. Interesting in the north, this is really the main area where there's lots of jobs up here, New York, Massachusetts, where there's lots of companies that actually hire technology people and so on. So they really have lots of technology as well as hospitality, tourism and so on, and maintenance job. So all the states are all different depending on where you're looking for a job. So we told the students you're better off actually going for a job in Texas, Florida, or stay up here in New York. Then we looked at the different occupations. So this bar shows you, so every column represents a state, with Texas being the first one, followed by New York and so on. And the color represents a type of job. So if you can see the blue one, this is really the farmers, laborer, landscape, right, in blue. As you can see, it's the most common category to get approved because people really require farmers. In orange is housekeeping, next one. In green is the groundskeeper, basically gardeners, and then in red, cooks and so on. So as you can see, right, there's different requirements for different states. So let's say you are a cook, then you have a better chance in Florida, Massachusetts, or Maine, where they have more tourism and so on. So the pattern is not the same for all states. So states like Texas, Pennsylvania, and New York really have the highest approval, basically depending on outdoor labor demand. Tourism heavy states like Florida, Maine, and North Carolina have a higher number of housekeeping, cooks, and server positions, where there's lots of restaurants and hotels. Smaller states like, South Dakota, Kentucky, Alabama, and so on, they have very few approval and actually very few demand as well, and not many seasonal or industry level jobs. So really this says that, some states really require certain jobs. If you're a cook, there are better places to look for a job compared to, let's say, you are a forest worker and so on. Okay, so that's it to summarize quickly. So we looked at the approval decision, and there's a very interesting and clear measurable patterns influenced by different factors: the wages, the job type, which state, and are you full-time or part-time, as well as, oddly enough, the size of the company. By looking at 17 years of the H2B data we looked at, we noticed that there are strong geographic and occupational trends with different places, with landscaping, construction, and hospitality dominating the approval. This is really where most of the jobs are. We tested two models. We used logistic regression and random forest, and we noticed that logistic regression performed better with 96% accuracy and balanced metrics for both approvals and denial. Random forest did well, but did not really do well with the approval compared to the denial. Overall, we looked at machine learning. It's a very good way to improve transparency and actually support better policy decisions, and very good for looking for jobs according to different locations. And this really helps in looking at forecasting and deeper labor and market analysis for the different states. And that's it. Thank you. Questions?
Okay. So more recently, we have seen that visa acceptance in the USA, it is being influenced by the changing immigration policies and the rules. So does your model account for policy shifts over time?
Yes, actually, because there have been lots of different shifting over time. So we removed this factor for this paper because it's a whole different field in itself. So we noticed that some years, because of politics, I don't want to mention the details, but some years you get lots of approvals, and other years you get lots of denials for political reasons, not really for actual job trends. So this is why we try to remove this factor from our research to make it more fair. We don't want to go into politics, you understand.
And any specific reasons for using the two models that you have decided? I think they were random forest and logical regression, because
Yes,
there's
those are the
explainable
ones.
AI. Yes, yes.
Yes, there's actually 5 or 6 different models that they tried, but those are the
Okay.
ones that gave the best results. So this is why we included those two in the papers.
All
The
right.
others gave us accuracy of about 80%, 85%, and so on. So
Okay.
rather than saying all of them, we just picked the best two, if you will,
Yes.
for the paper.
All right. Good one.
Thank
Nice to see you again. Thank
you.
you.
Thank you.
All right, now we'll be moving on to our last presentation for today. We have Zinab Alaoui, who will be presenting Quality-Driven Governance in Higher Education, a model for equity, innovation, and institutional transformation. Zinab, you may now begin.
Thank you. I don't know if you see my presentation.
We can see your screen.
It's okay?
Yes, you could start with the presentation. Your screen is visible.
Okay, thank you. So, good afternoon, everyone. Thank you for being here. I'm Zina Barawi, professor in university. Today, I will speak about rethinking in education driven by quality. I will try to explain why universities must move from simple administration to structured quality-based. So I have parts to share with you: global context, governance and quality assurance, standards, alignments, and effectiveness. Universities today face growing responsibilities and pressure. Higher education institutions face lots of challenges, including stakeholder pressure, globalization, for international recognition, cross-border mobility and of students and faculty, digital revolution, digital platforms, massification, and labor market demands for alignment with competencies between nations. So we need structured governance able to manage this complexity. Governance is not daily management. It is the system that defines strategic direction, ensures accountability, and structures institutional decision making. The objective of this research is to design a governance model aligned with international and national standards while integrating digital transformation and continuous improvement. So before presenting the governance ecosystem, it is important to clarify what governance means in higher education. According to Hayden and governance refers to the structures and processes through which institutions develop and implement policies. Society and colleagues also highlight that governance includes both formal and informal mechanisms guiding decision making. The literature shows that governance has evolved. Universities moved from initial models with strong academic autonomy to more structured and performance-oriented systems. Overall, governance today combines accountability, quality assurance, and digital transformation. So governance in higher education doesn't operate alone. It works within a system that involves many actors. These actors include internal stakeholders such as students, professors, and administrative staff, and external stakeholders such as ministries, quality agencies, and socio-economic partners. Each stakeholder has expectations and demands. Governance must therefore balance these expectations, translate them into clear policies, and organize them into structured processes. So, because of this complexity, governance cannot rely only on informal coordination. It requires a structured and systemic quality assurance system. This leads us directly to the role of quality assurance. Quality assurance shouldn't be understood as inspection or control. It is a systemic validation mechanism that ensures institutional coherence, ensures alignment between mission, strategy, and operational outcomes, performance measurement through indicators, risk identification and mitigation, and also continuous improvement cycles. Without quality assurance, governance remains declarative, and with quality assurance, governance becomes measurable and auditable. So quality-driven governance aims to move institutions toward maturity. Its objectives are institutional coherence, ethical and transparent decision-making, strategic alignment, measurable academic performance, and stakeholder satisfaction. Our methodology relies on comparative analysis and normative mapping. Our research proposed an interaction matrix aligning the international standard ISO 21001 principles and requirements and the Moroccan framework files. So governance reform in Morocco is reinforced by the national framework, which structures within 5 files, governance and support, training, research, student life, and service to society. For the standard, the international standard ISO 21001 principles, we have 11 principles: visionary leadership, stakeholder guidance, process approach, evidence-based decisions, improvement, social responsibility, relationship management, accessibility and equity, ethical conduct, data protection, and involvement of people. The objective of this research is to integrate governance principles with management system discipline. So we have done a matrix between principles of the international standards and references from of to broken framework. This matrix demonstrates this part of matrix demonstrates compatibility between international standards and national requirements. The function benefits is avoiding the duplication of audits, ensure system coherence, strengthen integration, and improving audit readiness. Our model is structured around four governance pillars. Strategic oversights, define mission, vision, monitor strategic objectives. The second pillar, effective management, supervising academic operations, ensuring administrative efficiency, financial and risk stewardship, budget monitoring, risk assessment, legal compliance, and the fourth one, digital governance with KPI dashboards, data integrity systems, and secure information management. Governance is not only structural and technical, but also ethical and value-based. These principles ensure sustainable institutional development. So integrity for transparency and data protection, sustainability for financial and environmental responsibility, inclusivity for equal opportunity, innovation with digital transformation, excellence for academic quality, and community for societal engagement. These values ensure governance is transparent, responsible, and socially engaged. So a successful implementation requires leadership, stakeholder engagement, resource allocation, and strong digital systems. We need some key elements to implement successfully this. The model follows the PDCA logic of the plan, do, check, and act. Governance becomes a dynamic and continuous improvement process. To conclude, rethinking governance means for us moving from administration to strategic steering, embedding quality assurance as governance infrastructure, aligning international and national frameworks, and advancing institutional maturity and leveraging digital transformation. Thank you for your attention.
So quality actually is a very fuzzy term. So how do you define operationally, how would you define quality in your governance model?
Quality assurance in our governance model, we try to translate what we do in quality assurance in industrial area to universities. So we try to work on principles of quality assurance to build a culture of quality. And the result today that we have in our university, for example, is that we had changed the mindset for the administrative personnel, and we find the stakeholders ask us to the more in this way.
All right, thank you. All the best.
Thank you.
All right, so those were all of our presentations for today. I would now like to move towards the closing remarks. I would like to thank all of our participants for their incredibly informative presentations today and to their contributions to this session. And I would like to thank everyone for being a part of this international conference. I hope this session was informative for everyone, and I hope that everyone learned a lot through the presentations. On behalf of the whole team, I would like to thank you for your support during this 11th version and all the previous 10 versions of the conference. We will be happy to have you in the 12th version as well in 2027. All the presenters would be getting their digital certificates through email within the next 2 working days, and the publication will be live within 7 to 8 months. Kindly cooperate with Team ICICT 2026. I also would like to thank our session chair, Dr. Nuzhat Faiz Sheikh, for chairing this session. And I would like to present a token of our appreciation for her. Just give me 1 second.
Good day, doctor.
Sorry?
I did not present.
Just 1 second.
Okay, Ali
Um,
Umar Isa.
all right, we were done with all the presentations for this session. Could I please know what your session was?
Yeah, actually, I'm together with Ali Umar, but he's not feeling fine, so I will be presenting on his behalf.
All right, just give me 1 moment to check.
Okay.
If we can have your presentation now. All right,
Okay.
so we will now be taking, hold on, just give me a second.
Okay. Can I share my screen, please?
I'll just introduce your paper, just a sec.
Okay. Okay.
So Mr. Muhammad will be presenting on behalf of Ali Omar, and their paper is Detecting Dark Patterns in User Interfaces Using Logistic Regression and Bag of Words Representation. You may now begin your presentation.
Okay, thank you very much. My name is, good day. My name is Abdullah Muhammad Ibrahim, and I'm presenting on behalf of Ali Umar, that is not around yet. Can you see my screen, please?
Yes, we
Yes,
can.
we see.
Okay. Our topic for today's presentation is detecting dark patterns in user interface using logistic regression and back of words presentation. The presentation overview comes as follows. First, we are going to start with the introduction to dark patterns. Secondly, the problem statement, related works, methodology that has been adopted in this particular work. At the same time, the experimental results, discussions, and then finally, conclusion on future recommendation. What are the dark patterns? Dark patterns are deceptive UI design practices intended to first manipulate user decisions, coerce unintended purchases, induce involuntary data disclosure, undermine user autonomy. At the same time, they exploit cognitive biases and psychological vulnerabilities in a particular model. Why does it matter? It reduces user trust, violate privacy, create negative user experience, undermine ethical design principles. At the same time, they appear across first commerce platform like the eBay, the Amazon. They also appear on social media like the Facebook, Instagram, or Twitter, and then in our mobile application that we normally use within our mobile phones. The research objective of this particular work is a machine learning approach for detecting these dark patterns using first logistic regression, bug of words, which is BOW representation, and then TF-IDF feature extraction. The goal of this particular work is to improve automated detection. Secondly, to ensure interpretability, at the same time to support ethical UI governance. Before conducting this particular work, we conducted a very thorough, comprehensive literature review of some related works. We consider some foundation of the work, the conceptualization of dark patterns, taxonomies of deceptive practices, at the same time machine learning approaches that include random forests, which happens to be uh, uh, particularly a random forest, which happens to be one of the key models that we actually consider of ensemble technique, and then transformer model, specifically the robot. The data set we consider, firstly, source of public GitHub repository. Total instances of, we had total instances of 3,636, of which 1,818 dark patterns, and then 1,818 non-dark patterns. The platform we covered, we include e-commerce, social media, mobile apps, and then the gap we actually identified. First is the need for interpretable models. At the same time, an ethical explainability, which is DPR compliance. Here is the dataset summary of the dataset we actually consider. We have the category of instance and average length, the dark, which is 1,818, and then we have the length of 120 watts, and then non-dark, which is also 1,818, at the same time with 110 watts. Balanced data set ensure robust training, like we actually all know. The data pre-processing, the steps perform the HTML tag removal, the punctuation cleaning, stop word removal, the lemmatization, regex normalization, feature extraction, and what have you. And then during feature extraction, lexical indicators of dark patterns, examples, the limited time offer, act now, subscribe to continue. This reflects urgency manipulation, at the same time, sarcastic cues, at the same time, obscured options. Bug of words representation. Bug of word representation, text converted into numerical vectors. We consider count vectorizer and then TPDI vectorizer. Turned maximum features, n-gram optimization, which actually enables machine learning classification. The model training, like we initially made mention of logistic regression classifier. The binary is, we all know binary classification. The dark patterns, non-dark patterns, and then hyperparameter tuning, as you can see. Here is the formula that we actually consider, like the feature vector, the parameter vector, and the probability of dark patterns. We consider these particular matrices, the accuracy, the precision, recall, F1 score, ROC curve, and then the AUC. This particular matrix actually ensures balanced performance evaluation. And then experimental result. At the very end of our conduct, here is the experimental result that we actually obtain. The accuracy happens to be 92%, then the precision 93%, recall 94%, F1 score 93%, at the same time AUC 97%. This actually demonstrates strong predictive capability and robustness. Here is a model comparison, logistic regression, the random forest, and the robota. In terms of accuracy, as you can see, logistic regression has 92%, F1 93, at the same time AUC 97. Random forest got 89 accuracy, F1 89, at the same time AUC 93. Robota 95% performance of accuracy, 96 of F1 at the same time, 98 for the AUC. The observation here in this particular model comparison, as we can see, we can observe that Roberta has the highest accuracy, logistic regression, best interpretability, performance balance. Confusion matrices, it actually illustrates true positives, false positive, true negative, false negative. RUC curve shows strong discrimination power. Future importance analysis. Top predictive phrases, limited time offer, subscribe to continue, act now, then interpretability achieved through coefficient magnitude, sharp explanation alignment. Then sharp interpretability reveals additive contribution to lexical cues, surface level dependency of BOW, limitation in semantic nonce detection. Example like the limited time offer, when concatenated with the subscribe to continue, give a strong positive contribution. Quality error analysis, starting with the false positive. Limited seats available for today's webinar, for example. The urgency but not deceptive. False negative, you may want to actually explore our premium options. Supple persuasions without explicit markers. Then here is the discussion. The key insight here, logistic regression given transparent and explainable, suitable for GDPR compliance, competitive performance, support ethical governance, and the threat of accuracy versus interpretability. Practical implications. This particular model actually can be integrated into UX design, user interface, user experience, design flows, workflows, browser extensions, compliance monitoring system, digital governance framework, so which support GDPR, CCPA, and ethical user interface standards. In conclusion, this particular study actually demonstrates effective detection of dark patterns. At the same time, it balances performance and interpretability. Also provide transparent machine learning framework, and very lastly, advances HCI research. Thank you very much. I've come to the end of my presentation.
As per your results, Robot A gives you the best performance. Can you justify the reason why does it give you the best results?
Yes, come again, please.
As
Come
per
again,
the
please.
results that you had displayed, Robot A
Yes,
gives you the best results, best accuracy. I think around 95% if I'm not wrong.
yes.
Can you justify your results? What's the reasoning behind it?
Okay, actually, when it comes to robustness, like these particular classifiers differs based on some certain features they contain actually, and at the very same time, after I conducted thorough data collection, after a lot of refinement and everything, I actually got to find out that it got the best performance.
Because there are many more methods. We have perceptrons, neural networks,
Yes,
explainable AI, which give much better results. Why did you stick to only these three methods?
yeah, actually, I before I chose this particular method, I conducted some comparative analysis of this particular method you actually mentioned. And then I got to find out based on the future research conducted, I come to realize that this particular method best fit this particular work.
All right. Thank you and all the
Thank you.
best.
Thank you very much.
All right,
Risha, are we
so
done with all the presentations?
yes, we are. We have concluded everything. So, as I was saying initially, I would like to present a certificate of our appreciation to the chair. Uh, Thank you for your valuable presence. Thank you so much for being here. And thank you again to all the participants for their wonderful and very informative presentations. Just before we end the session, I would like to request everyone to please turn on their cameras for a virtual snapshot of the meeting. All right. Thank you so much, everyone. Stay safe and take care.
Thank you.
Okay.
Thank you very much.
Thank you.
Thank you.
Bye-bye.